adding and subtracting polynomials. When you add or subtract polynomials, all you need to do is combine like terms. Remember, like terms must have the same variable and the same exponent. Example, 3xy plus 5xy both have x and y. The x has the invisible 1 as the exponent, and the y's have the invisible 1 as their exponent as well. 3xy plus 5xy gives you 8xy. Example number 2, as you can see, has the like terms noted by the circles and rectangles. 2x squared and 5x squared can be combined to give you 7x squared. 4y and 9y can be combined to give you 13y. Now I will go through some examples. Make sure to copy these as you go through your worksheet. I will denote my like terms by using circling, boxing, underlining, and any other necessary items. When you combine 2x cubed plus 3x squared minus 2x plus 4 with the polynomial of 4x cubed minus 6x minus 7, you will have 6x to the third plus 3x squared minus 8x minus 3. For example number 2, you have the polynomial x squared minus 3y minus 3 being added to the polynomial 2x squared plus 2. When combining your x squared terms, you have 1x squared plus 2x squared, giving you 3x squared. When you combine your x's, the only x term that you have is negative 3x. For your constants, when you combine negative 3 and positive 2, you get negative 1. Your solution is 3x squared minus 3x minus 1. Now I will work through these two examples. Try these two on your own and check your answer. Notice that each of the answers that I have written down are in standard form, starting with the highest exponent all the way down to any constants. Check your answers for these two problems. When subtracting polynomials, there is one extra step that you must do before you can combine. That extra step is to distribute the negative 1 that's sitting in front of the second parentheses. Notice the terms in the first parentheses did not change. Now that I've distributed the negative 1, I can go ahead and combine like terms. Your final answer is 3x squared minus 3x plus 10. Let's do the same thing with example B. When you distribute the negative, you get negative 6 minus 3u squared plus 4u. When you combine like terms, you should come up with negative 3u squared plus 5u minus 10. Go ahead and try these two next problems. Notice I distributed the negative 1 into the second parentheses, which gave me negative 2 plus 7y cubed minus 9y squared. Now I will combine like terms. Your solution should be 7y cubed minus 12y squared plus 5y minus 1. For the next example, make sure you distribute the negative 1 sitting in front of the second set of parentheses. Now that I distributed the negative 1, I can go ahead and combine like terms. When combining like terms, your solution should give you negative 2t squared plus 2t plus 5. Sometimes you need to distribute before you can combine like terms. In these next few examples, you will notice how we distribute and then combine like terms. When I go to write my solution, notice how I will keep the variables in alphabetical order. The solution comes out to be negative 2a plus 27c. I will follow the same steps as I did before. Step 1 is to distribute, then combine. Notice your constants are opposites. Negative 12 plus 12 would give you 0, therefore they cancel each other out. Your solution is 10a. For these next two examples, I will follow the same process, distribute and then combine like terms. Remember, when you write your solution and when you're combining like terms, to keep your answers in standard form, starting with your highest exponent. Your solution comes out to be 14y cubed minus 27y squared plus 15y minus 1. Now that I've distributed, I will go ahead and combine like terms. The solution I came up with was 12t squared plus 33t minus 93. Remember, when you are adding or subtracting polynomials, simply combine like terms.